Hello everyone, welcome to a new lecture. In this video we are going to talk about motion drivers. In the previous lecture we talked about how the continents move, and since the continents are on the plates, when the plates move, the continents also move. This was the explanation for continental drift. But what we did not talk about, why these plates that compose the Earth's crust move. We did not talk about the mechanism that leads the movement of the plates that compose Earth's crust. And in this lecture, we are going to talk about that. So the question is, what drives plate tectonics, or what drives the plates to move? Well, there's a bit of sad news. Geologists and geophysicists don't actually know why the plates that compose Earth's surface move. They do not have a clear idea, but there's a strong hypothesis that says that the plates on Earth move due to convection. And what convection is, it's simply upwelling of magma from underneath. So you have magma current coming up. Since the magma is hot and the oceanic crust is cold, so you have hot material coming up, you have cold material sinking down. Just like if you have a glass of water and you boil it, the water in the glass is cold. If you boil this, the top of the water is cold, the bottom of the water is hot. The hot water is less dense than the cold water and will rise to the surface, and the cold water will sink to the bottom. This creates a current. Just like here, we have an oceanic crust that is cold, we have mantle material that is hot. This creates a current or upwelling of magma, which is called convection. So this upwelling brings magma upward and it makes the cold oceanic crust to go down. Geologists and geophysicists strongly believe that the movement of plates on Earth's surface is due to convection, is due to mantle upwelling that brings hot material to the surface and it drags down cold material. So in divergent plate boundaries, in these areas are a place of creating new plates. In convergent plate boundaries, in these areas, you have old plates sinking down and dying basically, because when they go to the mantle, they disappear and they melt. So divergent plate boundaries, these are birth of new plate material. In this area are destruction or death of old plate materials or old crust materials. Scientists believe that there are two noticeable mechanisms to drive the whole convection process. Or there are two forces. The first one is called slab pull. Slab pull occurs because cold slabs of oceanic lithosphere are more dense than the underlying warm asthenosphere and hence sink like a rock. The density of the upper asthenosphere is about 3.25 gram per cubic centimeters, and 100 million years old oceanic crust is about 3.28 gram per cubic centimeters. There's a density difference of 0.03 grams per cubic centimeter. You might say, well, this is not a lot to drive the whole convection or to drive plates down into the mantle, but this difference, scientists believe that it's enough to drive that, because imagine when you go into a water, you try to swim, the difference between the density of the water and your body, it's not that much, but you don't sink because you have air in your lungs. When you exhale the air from your lungs, you immediately sink. So a fraction of density can make a lot of difference, and scientists believe that this difference between density of the upper asthenosphere and 100 million years old oceanic crust can actually drive the plates or to pull the slabs of the oceanic crust down to the mantle. So geologists and geophysicists contribute the pulling of the slabs to a mechanism that is called slab pull, or they contributed to something that is called ridge push. Ridge push is a gravity-driven mechanism due to elevated positions of the oceanic ridge, which pushes and causes slabs of lithosphere to slide down. So as you can see, when mantle comes out, it creates ridges, and these ridges are kind of like mountain shape. They are heavy. Scientists believe that gravity acts on these mountains, and as a result, these ridges pushes the slab downward. This mechanism does not create a lot of force. It accounts for 5 to 10% of the force causing motion in plates. The majority of the force that causes the plates to move or move downward is slab pull, which is due to less dense mantle material coming to the surface and 100 million years old cold oceanic crust sinking to the bottom. And remember, scientists for sure, they don't know whether convection is the mechanism that drives plate tectonics, but they strongly believe that convection might be the driving force behind plate tectonics or behind plate motion. And these two mechanisms, slab pull and ridge push, they believe that these two mechanisms create 99% of the force that drives old oceanic crust downward into the mantle. And with this, we come to the end of our lecture. So to recap,